Kia ora and welcome. My name's Justin Mills. I'm the equipment specialist for Repco for the Lower North Island. I'm here at the Universal College of Learning in Palmerston North with a good friend and colleague, Lance Fennell, and we're going to teach you and show you how to use the Stenhoj / Opus gas analyzer. Was owned by Opus, now been bought out by the company Stenhoj in Sweden. So this is the SGA 40-50. The difference with this machine and the standard SGA 40 is the SGA 40 is only a petrol gas analyzer. The SGA 40-50 has on this side here the Opus, the opacity meter for being able to do diesel. So what we're going to do is we're going to start off on the back and then go right through how to put the machine together. We know you guys are in Fiji, and sorry Bulla to everyone in Fiji. We know you guys are going to be putting these machines together as you get them. So what I'm going to do is spin the machine around. I'm going to go through a bit of a setup first on how to set these machines up. So what we've got on the back here, obviously you'll have your probe. This is your standard probe for doing petrol engines. You'll see on here you've got a filter. Now the filter side itself connects to the gas side up in here, and obviously the gas water is the other hose. So it's obviously a combination of two hoses all in one. You've got your probe that pops into the back of the vehicle, and obviously the clip here that helps it clip onto the back. So this is how you fit that up. They're long enough to be able to do just about any petrol there is on the market, and that's how you connect them all up. Your filters and everything else on the back here should be already connected. You've actually, with this machine being having the diesel unit as well, it'll have the extra power pack here to power up the diesel opacity meter as well. So you've got your O2 sensor on the back there. Really, an O2 sensor has a shelf life and a time life, so you will have to change them and change the filters periodically. The machine will actually tell you when they're due to be changed, so we can move forward from there. On the opposite side of this machine, we've got obviously plugged into our opacity meter, which is through the front of the machine as well. So now if we're going to be doing this diesel unit, what we're going to do is I'm going to turn this back to what we were before. I need to just show you some other connections that we need to do to have the unit up and running. We have this fella here, which is invaluable. Talking to Lance has used this machine quite a few times. This is the LCD remote, and on this you can do a lot more on this than you can on the actual screen itself. It allows you to be able to scroll through all the systems and be able to either enter into the systems or change calibrations and so forth. There's a really big magnet on the back, so wherever you put it, it will stay there. On the front you'll see all our meter, HCCO, all your standard stuff you're going to see with a full gas analyzer. Lambda and CO and percentages and so forth. If you've got NOx fitted, you'll have a special NOx sensor for the back to be able to read NOx as well. So really what we're going to do from now, Bruce Francis is going to do the first part of this video. He's going to have the assembly side. Just when you get it, these cabinets are actually flat packed, and he'll show you how that gets assembled and how the head unit gets bolted on there. Very tight little unit, very solid. So what we're going to do now is both Lance and myself are going to go through and set this up to be able to do a diesel vehicle, or my diesel vehicle here, and show us what the opacity readings are. So what we're going to do now is set that up. To set that up we need the oil temperature probe. What was the other one, Lance?
And the RPM.
And the RPM probe. So we've got two probes that come in the kit as well. So we've got an oil temperature RPM probe, which is this fella here, and the white one is the oil sensor. Now what it is this actually comes up to, you actually make that up to the length of the dipstick. So it sits inside the oil and measures the oil temperature. What you don't want is the vehicle overheating. So they plug into the back. I'm going to probably turn this machine around a few times so that we know exactly what's what. They plug into the back of the machine, and here you've got oil temp and RPM. Now this is only designed for the diesel side of this. So I'm going to go and plug those in now. And what we'll do very soon is we'll come back to you after we've hooked this up. Hi and welcome guys, welcome back. Now this is the next part of hooking everything up to do diesel readings. Everything is run through the LCD screen on here and not through the screen on the actual analyzer itself. So the screen on the analyzer is basically used for petrol. All your diesel readings and everything else will go through here. Alright, we've got a whole lot of buttons on here. There's either Y for yes, N for no, and you follow the prompts as it goes through. This little lead here, don't forget we spoke about our oil temp gauge, and we have to make that lead long enough to be able to go to the oil. So it needs to go from here to at least the minimum mark on your oil. Alright, doesn't have to go the full length, but at least the minimum mark in one of the notches that are on here. Okay, so that way when you put that back into there, that probe should sit in the oil and should read the exact oil temperature. Our other lead here just goes to the battery that picks up our RPM. So what we're going to do now is, between Lance and myself, Lance is going to zoom in on the screen. I'll start the vehicle up and we'll run through a test and we'll show you how we do that. So as you can all see on the LCD screen, it's a very small screen, so we've had to zoom the camera in on it. It's got acceleration, set up cylinders, the amount of cylinders you've got that you're going to be reading, a printout, a zero calibrate, so you can control everything you need to do with this gas analyzer off the LCD screen. So if you have a look at all the buttons, there's up and down arrows. As I say, there's only a couple of really key things to do is make sure you hit yes for Y for yes and N for no when you're going through the steps. So as we go down, we can go set up. You'll see it flashing on the setup cylinders. We hit our enter button down here. So it says make sure that we connect the RPM and oil probes. Have we done that? Yes, we have. We press Y on here and then enter. So it says keep the idle speed, input number of cylinders. We've already done that. We've said 4. We hit enter there again. It's initializing the setup, RPM measurement. Keep the idle speed, and obviously it says wait until we're ready. So Lance is going to operate that. It's going to ask us to accelerate. I'll go to the other side of the vehicle and we'll do the acceleration from there.
So now it's actually come up to see whether or not you want NZTA approved or VTNZ approved. Unsure what your system you're using over in Fiji, but use the required one that suits your regulations related to Fiji. We're going to choose NZTA here, so it's button 1. Okay. And is the exhaust system okay? And we're going to say yes, it's okay, so we go enter. Okay. Is the oil temperature 60 degrees minimum? So that would have come up before. Yes, it is. Then we're going to do our acceleration test. So I'm going to push enter to start, and Justin's going to give it a rev up. So we're going to go enter, and you've only got a small time frame to do it in. And as you can see, we've actually come up with our opacity of 0.4K. The RPM went to 6.2, the oil temperature's at 61, so it was over 60, and the vehicle claims it's approved. And then we push our Y button for our printout. It'll print something off. Justin will tear it off for us and show you. We won't put the vehicle input data, but would normally say it's a Nissan Navara, or the registration number.
So here's our printout. Obviously it's got acceleration. Now don't forget these specifications are NZTA approved or BTNZ approved here in NZ. You'd have to check in Fiji to what your regulations are there. You can change them accordingly. You'd have to go through the machine and change them. So obviously it meets the requirement and it says that it's approved. So really that's pretty much it, guys. So if there's anything else you need. Hi team, I'm back again. Once our gas analyzer is ready, it'll actually come up with pause. As you see it going across the screen there. Right, that'll do that all day while it's sitting there, while you're not using the machine. Once you're ready to go, you can push any one of these buttons. It'll come up, it'll calibrate it, it'll go and calibrate everything that's sitting on there in each one of those categories. And then it should tell us when we're ready to go. So as you can see there, everything is ready to go. Our CO, our CO2, our O2, which is our oxygen. Now obviously talking with Lance, obviously this may differ in Fiji as well, and depending on how clean the oxygen is, actually measuring the oxygen that's around us right now. So
Generally speaking, good clean air will be about 21% O2. The others should be showing zeros. If you have any reading above 20 on the HC square, anything above 20 parts per million, it will need to run through a calibrate and leak test because it's already got residual HC in the line or sniffing it. So you need to be in nice clean air for it to do the calibration and come up like this. And as you can see in our current shop, it's only showing 1 or 0, so it's actually calibrates ready to go.
So one thing Lance did actually just tell me then, just before we got this going, is to make sure you do not, if you've got a really smoky vehicle, you do not hook the machine up to it because it will actually ruin the actual test unit itself. It's got a bench inside there that is very, very sensitive. It measures all of these, everything that you see on the display. If you've got a really, really smoky vehicle, it will discolour the bench inside it and actually ruin all your readings, and you more than likely ruin the machine itself. So just make sure you don't use anything that's blowing black smoke. It's a petrol engine that's blowing black smoke or anything like that. And that's why we have a diesel opacity meter below for diesels, because of that simple reason. So what I'm going to do now is I'm going to go and hook up our little unit into the exhaust system of this vehicle, and then we're going to see what it does from cold as it progresses through its warm-up stage and then gets to operating temperature, and you will see everything change on our gas analyzer there. So just remember team, every time you insert this into the pipe, it goes right into the exhaust pipe itself. So that means the only readings you're going to get are the gas out of the vehicle itself. So you may even need to get a clip or something to hold it in place. Okay, so what we're going to do is we will start our vehicle up.
Tell them about wind. If you actually get any wind, or you're actually testing it outside in wind area, make sure the prevailing wind is not blowing towards the exhaust pipe. It can actually give you an inaccurate reading as fresh air blows up the exhaust pipe and the sniffer starts sniffing the fresh air, so it can give you incorrect readings. So you need to block the wind from actually blowing near the exhaust pipe.
So now what I'm going to do is I'll start the car, and then you'll see the readings change from there. The car will be from dead cold, and then as it warms up you'll see everything change. Yeah. Right. It also shows you the sensitivity of the machine itself and how accurate it is in picking up any of the readings that are coming through this vehicle right now. Remember, this car is cold. Normally if you're checking a vehicle, depending on what you're checking it for, if it's a hot vehicle that's just come in and you just want to check some readings to make sure everything is working fine, you would normally have it at operating temperature. So So with your hydrocarbons, if you can see there, so hydrocarbons, remember, is parts per million. All right, so when the vehicle is cold, obviously the catalytic converter is cold as well. So as it's warming up, so between 50 and 500 million parts, or parts per million. So that everything is measured in parts per million. As it progresses and gets slightly hotter, your hydrocarbons will change from 50 to 500 down to 5 to 30. Your CO is, when it's cold, is normally 0.5 to 1.5. Now these are percentage, everything else is in percentage. The only thing that's in parts per million is hydrocarbons. And as it progresses, as your CO gets warmer, it'll go from 0.05 to 0.5%. Your CO2 is 12 to 14% when it's cold, and as it warms up it'll go from 14 to 15.5%. It's measured as percentage again. So your O2, which is your oxygen, is 1 to 3% when it's cold. When it's warm, it's 0 to 1% as it warms up. Now, oxides of nitrous.
Oxides of nitrogen.
So it is 0.9 to 1.1 when it's cold, and 0.97 to 1.03.
But tested under partial load on dynos.
But tested under partial load on dynos if you're going to do that. So whenever you're trying to measure oxides of nitrous, you need to have the vehicle under partial load. So everything else you don't need to. It will read exactly as it is right now. So as you slowly see this
and
vehicle,
lambda. And lambda.
and lambda as well.
Lambda should be 1.
Yep.
Yep. And lambda should be 1 because that's our basic air-fuel ratio mix, or a proportion of. So if it's as close to 1 as possible, it means the car is burning efficiently. It's right at the perfect mix. As you can see, this one is currently running smack on 1, so the computer, the O2 sensors, they're all compensating, telling the injectors what to do to keep it at that 1 mark. So a faulty O2 sensor will make that change because it doesn't give feedback back to the computer, so it can't tell the injectors what they need to do. So the basic readings are, if the engine is nice and warm and it's a really good vehicle, everything should be pretty much, CO should be 0, CO2 should be 14.5 to 15, HC should be 0, O2 should be 0, oxides of nitrogen really low, and lambda should be 1 to show it's a very, very good car, and you can print out for the customer and say, your car is running mint. Yep. So I'll just hold a few readings. So when I accelerate, you should see the HCs go up because it's petrol going in initially for acceleration. And as you can see, the CO is 0.02, which is almost 0, nothing. HC's dropped down to 3, which that's 3 parts per million, which is basically nothing. And O2 is pretty much 0.04, and our CO2 15 odd, it's got to be around 15, and our lambda stayed at 1. Very, very good car.
So does that mean the catalytic converter and everything?
That means everything in the car is working. Catalytic converter, everything's working mint.
So there you go, team. Hopefully that sort of gives you an idea of how how this piece of equipment works. I'd just like to say a big thank you to Lance and obviously the team here at UCOL and Palmerston North for allowing us to use their equipment and obviously their camera gear and so forth to bring this training video to you guys. So thank you very much, Bolivar Naka, and I'll talk to you very soon. Thank you.